I'm from Stockholm, Sweden myself, and I'm here to talk to you about the Postgres replication protocol. And I'll just give you the warning ahead. I've started this sort of a tradition with going to any kind of conference in the US whereby I always get a cold and sort of halfway lose my voice. It's doing unusually well so far, but if it suddenly goes away in the middle of the talk, you're warned. Then just read the slides. And I'll sort of stand here and do some sort of a dance or something. So the Postgres replication protocols, the protocol, the tools, and the opportunities that we have around it. And we're talking about the Postgres sort of built-in replication that was added in Postgres 9.0. How many in here are already using this for replication, just your streaming replication stuff? What the hell are the rest of you guys using? Are you still using Sloaney? Okay, somebody probably is. So or you're still using what came before that, which is basically the warm standby log shipping. And it really is the same thing. The replication protocol is entirely based on the transaction log, commonly known as a lot of different things. We use two terms very frequently in Postgres. We use the term WAL, which is write-ahead log, or XLog for transaction log. And this really is the same thing. So I'm probably going to use them in completely different ways during this talk. Just assume they're both exactly the same thing. The idea behind this Postgres replication method is we start everything. Did this one just go off? No? OK, we start everything from a base backup. And then we just use our standard crash recovery code. This is the same stuff we use if your system crashed, or if you're restoring from backup, or if you're doing replication. It's all the same code path. It's the same methods we're doing. And the replication protocol is layered on top of the standard Postgres protocol, which is what you'll be using when you're running your regular queries, which actually turns out to be quite useful. And I'll say, I don't think any one of them is in here, but I'll just say I was opposed to parts of that in the beginning, and I've changed my mind. I've had to say that the last time because one of the guys who really had to work hard to convince me was in the room, but he's not here now, so I'll get away with it. So some of the things we're going to look at, basically how connection processing and startup works in Postgres at all. The Postgres protocol and exactly what we had to tweak in it to make it work. It's surprisingly few changes to the protocol to be able to carry this replication over the same thing. And then the tool that came in, I can now say that because it was released in Postgres 9.1 on Monday, which of course you're all still using, or already using, those of you who were using streaming replication, right? You're already using all these tools from 9.1 because they've been out for like days now. I mean, why wait? In particular, the PG-based backup, which is the part that came in Postgres 9.1. We've got more things coming up in future versions, but that's the one that you have right now. So when you do a normal client connection in Postgres, okay, let's start with that. We use TCP. Okay, we're going to ignore the fact that you can also use a Unix local domain socket. It works exactly the same way. We're starting over a TCP connection, port 5432 being the Postgres standard port, right? And what we do pretty much right away in Postgres is we're going to fork a new process. I'm sure you'll know Postgres process-based. Every new connection gets a new process. We just use a fork. We're not going to go into all the ugly and hideous things we do to make that work on Windows where fork doesn't exist. But in the end, it works pretty much the same. The first thing that happens once we've actually forked off this new process is that we're going to do the SSL negotiation. So it's basically a very simple one where the client says, I want SSL or not, and the server says, I can do SSL or not, and then they decide whether they're going to do it or not. Once we've done that, we're going to get the database name, the username, and any kind of connection options from the client. This all happens before we've actually authenticated. As you're sure if you've been working with Postgres for a while, you know the PG-HBA file, which controls how we do authentication, needs the username and the database name to figure out how it's going to proceed. So those all go in the startup packets of the exchange long before we figure out whether you're actually allowed to connect. And only once we have those, we do perform the authentication. And should this fail, we just close the process and go away straight away. And the authentication, usually we just take the username password and authenticate it one way or another. It can be the local password, it can be LDAP, Radius, whatever. This can also be a full Kerberos packet exchange. Stephen is happy with that. He's one of the people who both use it and actually find bugs in it. After that, we do something called the select database. A single process, a regular backend process in Postgres, will only ever talk to one database. So I'm sure you've noticed once you tried to do cross-database queries and it didn't work. This is where we sort of read and pre-populate the cache of important system relations, like the list of tables, the list of all the data. So at this point, this happens after we've authenticated. We try to do as little as possible before we know you're allowed to do anything. Otherwise, you could pretty easily denial of service the system at that point. And once we've selected the database, we enter the simple query processing loop, where we, client sends a query, we try to do something with the query, send back a response, and just go back into this loop. And we wait until the client disconnects. Now, this is the regular Postgres connection. If we turn this into a replication connection, it's mostly the same. We change a couple of things. Very few things. We do actually still have the step 4, which is get the database username and options, except the database name is always hard-coded to replication. If you set the database name to anything other than replication, it will not work. We do specify a username the normal way. And in the options field, we actually have to set an option that says replication equals 1 to tell the system that we really did mean replication, right? We weren't just kidding. And the important step here is that step 5 is all the same. We still perform the same authentication. This is one of the sort of 2 main reasons why it turned out to be a really good idea to layer this on top of the standard libpq protocol. So we can perform the same kind of authentication. If you have Kerberos set up for your regular connections, we'll just do Kerberos for your replication if you want, or SSL certificates, or username password. It is exactly the same code. It is the same, the replication client in the, if you're running the standard, what's it called, the WAL receiver, it actually uses libpq, the same connection functions that your applications are using. The other big thing we're getting here is obviously all the way up in step 3, the SSL support. Works exactly the same way with replication as it does with a regular connection. So if you want to set up your PKI-based certificate validation and all of those things, they work exactly the same way. And these are the parts that, again, I wasn't entirely convinced about them earlier on. I'm very convinced about them now. So I'd like to say it's my idea. It really isn't. But it turns out it works pretty well. Of course, we don't actually do step 6 and 7. We don't select the database. We don't enter the query processing loop. Instead, we start something called a WAL sender. So it's important to know that the replication connection is not actually connected to a database. Every other process that you get up in your Postgres system will be connected to a database. But the replication connection is not, which means there is a whole lot of infrastructure within the Postgres backend system that it does not have access to. But what it does, again, it starts the WAL sender, which is, well, the name comes, it's the write-ahead log sender. It takes the write-ahead log and it kind of sends it to the replication slave, which is the one we have here. It makes sense. So what really is the WAL sender? It is a special purpose Postgres backend. There are a number of special purpose backends you can find. A comparative example is probably the AutoVacuum, which have a launcher that is not connected to a database, and it has the workers that are connected to databases. It only accepts simple queries. It still speaks the Postgres protocol. The Postgres protocol has the concept of a simple query, and I think it's called an extended query. The extended query is the one where you can bind parameters and prepare statements and all that stuff. None of that is supported in the WAL sender. It supports the simple query interface, which is simply, it takes a string from the client. That is a query of some kind. It will return a mix of standard Postgres result sets and streams of binary data, depending on exactly what you're doing. But a number of the operations, you do actually return just the standard result sets, so that if you're using libpq, talking to this thing, it's the standard pq get value to get your columns and rows out of the result set. And there is nothing in this, since it's all layered on top of libpq, you can write your own clients. There is no sort of special magic done in it. In Postgres 9.0, it only has the basic log streaming. There exists 2 commands. And basically what happens is the client, in this case the other Postgres server, will connect to the master and just say, I'm here, I want your replication stream starting at this position in the transaction log. at which point the server will either start streaming this transaction log right away from this given position, or say, I don't have this position anymore. How many set up streaming replication and got that error? Really? That's when you have set your while keep segments too low. Postgres normally rotates the transaction log away from your master, and the while sender will just read it from the standard pgx log directory. So if it's been rotated off the master, you can no longer do replication. It means you need to start your replication within a certain amount of time from when you did your base backup, or the data will not be there and you have to restart from the beginning again. Can be annoying. So, taking a step back from the replication specific parts, the Postgres protocol itself, it's a very, very simple protocol. I have no idea how we've actually made it to protocol version 3 while it's still this simple. It is protocol version 3. There was a version 1 sometime, really, really long time ago. There's version 2 that is actually still supported by the server today. That'll be if you're using a client from version 7.3 or earlier. If you're doing that, please upgrade. Really, please upgrade. We're discussing just the other week to actually drop support for that old protocol version, but turns out we're not going to do it until we have to, but don't rely on it. It is message-based, completely message-based, bidirectional. Messages actually look exactly the same going back and forth. They just have different identifiers. It's optionally SSL encrypted, and when we do that, we just wrap the whole stream in a standard SSL encrypted stream. We don't do individual message encryption or anything like that. We just let the SSL libraries take care of the problem for us. Turns out that's what they were made for. So your typical message, again, it sounds very complicated. It is very simple. Your typical message, it has a message type. So there is a limited number of them. I think there is like 30 or 35 message types in total. A message has a length. It is 32-bit. You will not get a single message larger than that, which is probably good for you in any case, because we need to store this in memory on both the server and client side, and then just some sort of a message data. The actual format, obviously, depending on exactly what kind of message it is. So if we look at a standard query exchange, again, we're back to your regular, say, PSQL connection or libpq connection from your application. What happens is the server, which in this case is on the left, will send a message called ready for query, which just tells the client that, yeah, I've started up, I've attached to my database, things are looking good. This is the entering into this query processing loop. Every message has that. It sends a size, and then it sends some flags for your transaction status, which is just to tell your client that you're in the query loop and you're in a transaction, or you're in the query loop but you're not in a transaction. This is one of the things that were added in protocol version 3 to make it easier for clients to actually know whether they're in a transaction or not needing to keep track of it themselves. The client will then send a simple query message. And again, this is a very simple query. It will send the message queue, followed by the length of the string, and then just a simple string that is your query, such as select 1, 2, 3. At which point the server will respond first with a row description message that tells you this is a regular result set. And it'll list you the columns for it. For each column, it'll tell you what's the name of the column, what's the data type of the column, what's the length of the column, and if it's a fixed length column. And you'll get one of these row descriptions per query. And the simple query protocol will return one of them. And then you'll just get a data row for each row in your result set. So if you're selecting 100,000 rows, you're going to get 100,000 data row messages. This is one of the reasons why, if you're doing bulk loading or unloading, you should be using copy. Then you don't get one message with the overhead for each one of them. You can actually get a stream out of the data. This is the D-type message. That'll just tell you, again, the size and then the contents of the data. Once we're done, once we've sent you the whole result set, we'll send a command tag message. It's C, and it sends back the kind of command it did. So in this case, it basically says the command tag returns select, just saying, I completed your select command now. And that's the whole exchange for a simple query. Obviously, if we're doing advanced extended queries with parameter binding and all that stuff, we get some more stuff around it. But for the simple query, that's all we do. Now, if we take this and look at how this looks for a replication connection, it does look surprisingly similar. We start again with the ready for query message to go into this faked query loop, so to speak. And the client, which in this case will be the other Postgres server. From the view of this connection, it is a client. It will send the start replication and then a transaction log position. The sort of number/number is just the weird way that we write a 64-bit integer that is the transaction log position. The server will then respond with a copy out response, which tells you this is the same response you would have received if you did a copy command. You'll know the copy command, right, to load or unload data into your database. We'll send the same one. We just say the copy out response, and then we say there are no columns and there are 0 size. That's the one you will normally not get from a regular copy message. And then we just start sending copy data. We'll send a copy data that just is a block of transaction log data. And we'll just keep doing that, and we will never stop until you shut down the system. So if you look at it from a libpq perspective, you send the query, and then you just start reading row by row, and you just don't stop. The size of these xlog data blocks depends entirely on how the transaction log is generated. If you're running large transactions, the blocks that go over replication will be larger. If you're running small transactions, they will be smaller. And they will obviously be generated by all kinds of background processes, by your checkpointing, by your auto vacuum. All of these guys will generate these xlog data blocks that gets sent off. And in the regular, if you have a regular replication client, well, it'll read these blocks, it'll write them back down into one of these files in your pgxlog directory. It'll send them to the recovery process and just replay them as if it was doing it directly from file. So as you can see, the protocol itself, we're really doing the same thing. And this is exactly the same thing you would if you did a copy on an infinitely large table. Most people don't, but you know, they can feel like infinitely large sometimes when you're on an SLA requirement to get it back up. So we're adding some things to this in 9.1 that are available that I'm not going to talk about first. As you've heard, if you were here earlier, we do have synchronous replication now. I believe Greg Smith is on later this afternoon to actually tell you how to configure synchronous replication. Go to his talk if you're interested in this stuff. I'm going to be there. We also added something called a hot standby feedback loop. And both of these two, the main thing they changed from a protocol perspective is that suddenly the protocol is bidirectional. Okay, if you look at this one, once we've sent the simple query, all the data flows from the server to the client. In 9.1, there will be data going from the client to the server in the middle of one of these streams. For synchronous replication, well, we need the feedback to know when the transaction has been synchronized on the slave, so we know when we can release the transaction on the master. And for the hot standby feedback loop, we just tell the master about our MVCC snapshot data so that it knows which rows it should not vacuum away because we need them on the client. What we also did, that we turned the WAL sender into actually having its own sort of micro language, a very, very tiny subset of what it can do, but it's no longer fixed to doing just one command, which is start replication. It can do more stuff. It means we do have a full grammar. It's very limited in what we do. It takes very few commands, it takes very few options. It is really picky about the way you write things. Like, it doesn't support all the weird ways you can quote a string in SQL, depending on which GUCs you set to, standards conforming strings, on or off, or warnings. It just doesn't care about that. It is picky about what you put in there. It is not designed for you to run commands manually. You can do that. I mean, you can get the replication stream into your PSQL client if you want to. And it happens when you're writing these features that you do this by mistake, but I don't see a real actual use case for it. There are some other things that could be useful. The main thing about it is that it is a foundation for future improvements. We have the foundation layer. We can put more functionality into this WAL sender process as we realize that we have further needs. So what we've done in WAL sender, we have 3 commands available in the WAL sender in Postgres 9.1. 2 of them existed in 9.0 and look almost the same. One is identify system. That just returns a system identifier, the same one you'll find in PG control. And the current timeline, actually. That is the difference in 9.0 and 9.1. It didn't include the timeline then. We still have the start replication command. It has exactly the same syntax as before. And the new command we've added is base backup, which lets us have the WAL sender not just send WAL. So in theory, we should rename it. We're not going to do that. It's some sort of generic replication sender now. It will let you take a base backup throughout this. We have parameters for backup label, for progress, for how we control our checkpointing. I'm going to show more about those in a bit. But it's all very simple. It looks somewhat like SQL, but you can't put like subselects in there because we're not connected to a database. What this gives us is the single command base backups. Okay, I'm sure everybody has at least once written a completely broken script to do base backups. At least those of you who've ever tried it. You tend to do that. So with this, you no longer need to run PG start backup and PG stop backup. The system will just take care of that for you. You can control it through these parameters. You can control the backup label. If you look through this, you can control the fast sets, whether you want the slow or the fast checkpoint. This is the second parameter to the PG start backup command. And you can actually add more stuff to it. But we can replicate the functionality that we had. It has a couple of other advantages which are not on there, so I'll put them here. It does allow for concurrent base backups, which we don't allow on 9.0 with PG start and stop backup. You can only have one concurrent base backup running. In 9.1, you can have multiple concurrent base backups as long as you're using this interface, because we're still keeping the old method there. Your old scripts will still work. We have PG start and stop backup. Then you can only run one of them. Actually, running your multiple concurrent backups sounds like probably a pretty bad idea. But it turns out it can be useful when you're provisioning new replicas. You probably don't want to be running your standard backups more than once at a time. Yes, Stephen?
How do the PG start backup and stop backup interface, how does that interact with base backup again? You did both of them at the same time.
If you did both of them, you're fine as long as you only do one of them with PG start and stop backup. You can have one backup running with the old way and one in the new way concurrently. Works fine. So again, it's still not for manual consumption. You can use this. It is designed so that you can plug this into your third party if you're using Tivoli's Enterprise or Legato Networker or something. This is where you would write your modules these days. But if you're not using one of these extended solutions, you'll be using the PG-based backup tool that ships in the bin directory in Postgres 9.1. There we go. Which does your simple streaming-based backups. Now, what we do when we stream the base backups is we're actually going to stream them natively on the wire in tar format. Turns out it's a simple format to use that a lot of libraries already know how to parse, and it works real well for something that's streaming. For one thing, it doesn't actually have a global header. If you look at, for example, say a zip file, there's a header in a zip file that tells you which files are in it. Now, when we're streaming a base backup, we don't know that. When we start the backup, it might take you an hour to finish it. During this, Postgres will create and remove files. So when we started it, we didn't actually know which files were going to be in it. The tar file format tends to be very nice about that. It just lets us add the files as we find them to the end of the file and just add them there. It does align files. It aligns them on 512 byte binaries, which is not that expensive because Postgres tends to already align all its files at 8 kilobyte binaries. So the overhead is, for any regular data file, the overhead of that is 0. The only thing is for configuration files, things like that are on uneven numbers. That's where we will actually have a little bit of overhead, but it's very, very little. What we're going to do when we do a streaming-based backup is if you have multiple table spaces, you're going to get a separate tar stream for each table space. We're still going to send them sequentially because we only have one connection. So we're going to start by sending your PG default table space, and then every other table space as you added them, if you did, one after another. Oh, that's interesting. I was not prepared for that slide. So here's an example of how this looks. Sorry about that. So we got this standard ready for query message. we got the transaction status. We send the simple query, base backup, label foo. What we're going to get first, and this is the part where it differentiates. It's kind of hard to get standard SQL to get this out, but it works pretty well. We're first going to get a row description that is going to tell us, hey, here's a regular result set with 3 columns in it, SPC OID, SPC location, and size. This is the information about our table spaces. And then we're going to get 1 row for each table space. So we're always going to get at least 1 row. SPC OID is the object ID of this table space. Location is where is the table space. Size is optionally the size of this table space. By default, the size column will be null. And SPC OID and SPC location will also be null for PG default. For any other table space, we'll tell you where it is. And we're going to finish this result set the same way that we finished it for a regular query by sending a command tag with a select. And then we're immediately going to follow it with a copy out response. This is sort of like, if you're using the multi-statement requests, whereby you send multiple queries with a semicolon between them, and you actually send that all the way to the server. If you just do it in PSQL, we're actually going to send it as separate messages to the server. But if you do it from your own software, it will send them as one message, and you'll get multiple result sets back. So you need a client that can actually deal with the fact that you get multiple result sets back as the response of a single query. As long as you can do that, you can run this from any of the client drivers. We get the copy out response. It looks the same as the streaming one, and we just feed it the tar data. And eventually, once we're done, we're going to send you another round of data until we're done. We send the copy done. This is what will never happen with streaming replication, because we never actually finish that. This one we do finish. We send a copy done. And then we start sending the next table space. So this means that if you have 10 table spaces, you're going to get 11 result sets. 1 with metadata, then 1 with each of the table spaces. So again, using PG-based backup to do this, it's got a couple of very simple options. -D to tell it where to write its files into a directory. You can choose 2 formats for PG-based backup, plain or tar. Plain will just actually replicate the exact directory structure from your server into the directory that you point. So you'll get all the subdirectories and all the files in them. So we're basically unpacking the tar stream. If you're saying tar, we're just going to give you a tar file to do whatever you want with. -C will let you choose whether you want a fast checkpoint or a spread checkpoint. This is the same as the second parameter to PG start backup in the old way of doing things. -L will let you set the label. -C will give you the ability to compress the stream. If you do this, the compression is done in PG-based backup. It's not done on the server. So if you're running this across the network, the compression happens on the client. We don't support compression on the server side at this point. On top of this, we also do all the standard libpq client options, like the same way you connect with PSQL or pgdump, -H for host, -P for port, username, all of those things are exactly the same options as for all your other tools. So this backup runs just fine across the network, which is another difference with the old method whereby you actually had to access the files locally. So this lets you take a backup without ever logging into the server. Yep. Storage. Yeah, it'll give you a tar.gz file. Yeah. Well, you can run PG-based backup on your database server, and then you're on the same one. So there is certainly a use case for implementing server-side compression as well. We just haven't done that yet. Yeah, patch is welcome. Yes, we will get there. There is another option to this PG-based backup tool that can be useful, but that that has some side effects. You can add -P, and you will actually get a progress indicator, which is something we've previously been unable to do. Who have ever run a PG dump, come back 3 hours later, and wondered if it's 5% or 95% through? Yeah. Adding -P will give you a somewhat of a progress indicator. What it will do is it actually, when you run the start backup, it'll enumerate all your table spaces and look at how big the files are and just sum them up. And in this result set that it sent back, it'll say this table space is approximately this big. Now, we all know if this backup takes more than a couple of seconds, it's likely that the size of the actual backup differs from this estimation. So it's not an exact number in any way. But it will give you an indication, again, whether you're at 5 or 95%. It'll get that right. It does have an expense in that it will scan all your table spaces twice, once to find the size, and then once again to actually back them up. So it'll depend whether that actually becomes a problem or not. Will very much depend on how your database looks and what kind of an I/O performance you have in your system. There's one more feature that we do have around this, base backups and WAL. When we restore from one of these base backups, as you know, we have WAL archiving. We need to set up a restore command to copy the files back from wherever they happen to be and set up all that stuff. It tends to be a bit complex for the simple case. We have a switch in PG base backup that makes the simple case even simpler. If you add -x, that means that when we've done this backup, when we've sent all your table spaces, we're just going to send you all the WAL you're going to need to restore this as well in one big package. What that actually means is if you send this in the plain text format, it's going to put these transaction log files directly into your PGX log directory, and you can just start Postgres in that directory right away, and you have a clone of your database without having to deal with recovery.conf at all, which has some advantages. Now, what you need to think about if you want to use this is WAL keep segments. It's the one I mentioned in the beginning. If your backup takes 3 hours, you need to actually keep 3 hours worth of transaction log data on the master so that we have something to send you, because this is sent at the end. But if doing that, and in particularly in sort of smaller databases with not that much activity, just adding a -x there is a very, very simple way of just cloning your database in a way that is guaranteed to be perfectly consistent. So obviously, there are some things we can do about this. Part of this is, when I did this talk the first time, we hadn't even started on 9.2 yet. Now we've started on 9.2. Let's see how much of this we can get into 9.2. These are some of the ideas that I've heard from others. Some of the ideas I've come up with myself. If you guys have any good ideas on other things that should go on this list, let me know. We want to improve this further. One thing that actually there is code out there that almost works for 9.0 already. There is definitely code out there that works for 9.1 now, is streaming the WAL archive. Okay, you've all set up log archiving. In all these scenarios, we're still using archive command, which is fine in a lot of cases, but we have the whole 16 megabyte granularity that is a problem. We'll send a file off to our log archive for backups once every 16 megabytes, or once every archive timeout. So if we have a very low velocity database, we're either going to be sending a lot of 16 megabyte files that we didn't need to send, or we're going to have a long window of data loss if we crash. And the replication protocol has actually already solved this problem. We just need a client tool to use it, which is the tool called PG receive xlog. It is currently waiting in CommitFest 1, or are we on CommitFest? We're on CommitFest 2. In CommitFest 2 for Postgres 9.2, as an extension to PG base backup, that will basically let you run this PG receive xlog on your backup server or somewhere where it will receive the replication stream and synthesize a WAL archive for you. So you won't have the overhead of copying big 16 megabyte files with no data in them, and you won't have to wait for archive timeout. We'll be streaming the data live into your backup systems. If you're in a high velocity database, it's not going to be a problem today because you might blow through 16 megabytes of transaction log in like half a second. In that case, this is not going to make much difference at all. But if you do have a fairly low velocity system or an uneven velocity system, this will help you in keeping down the volumes of data in your archives to only the actual data that you need. Again, this code is actually out there. This tool, the changes required for PG receive xlog are client-side only. So this tool will actually work perfectly fine against the 9.0 database and the 9.1 database. It doesn't use any new, it doesn't need any changes to the backend. It's just a client tool. We're also going to need some way of preventing WAL cycling. Again, we had the problem in -X mode. We need the val to stay around till the end of the backup. That's a problem because you don't necessarily know how much val that's going to be, and it might not be the same from day to day. There are a couple of things we're trying to do this. There's actually a patch submitted for this about a week ago that was rapidly shut down with good arguments for making it better, but in some way prevent the master from recycling the val too early. That is something that we're definitely looking at getting into 9.2. That is obviously going to take a server change, so that's not something you're going to be able to run against your old servers. Another one is val streaming during backup. It's basically a combination of this receive xlog tool with PG-based backup. You know, if you run them all both at once, you wouldn't need to keep any val around. The idea being basically when we start running the base backup, we fork off a process that starts streaming the val while we're running the backup. And when we're done, we just stop. Yes?
This might get into a little bit of stuff, but have you considered having kind of multiplexing capability where you have each message coming back, which has like a stamp on it, and which frame this is coming from, and you actually do like table spaces to all these things in parallel?
It's been considered, but the main problem is you'd probably want to be running those out of two different val centers anywhere. Wait, to get performance. It's not going to be the stream that's your performance problem. It's pulling the data out in the end. So it's probably going to be more efficient to be able to run different table spaces over different connections. Yeah, we can argue that. There is also talk about sort of interspacing the val in the middle of the stream. Yeah, so there are things around that. Again, this is also code that's actually sitting on the commit fest, waiting for all you guys to review it. Well, maybe not all at once, but at least some of you guys could perfectly well review that. And it will work against existing versions. It doesn't change anything in the protocol. It's just a client-side thing. Another thing that you will run into this when you start doing this, and this is not actually related to the replication protocol at all, is relocatable table spaces. It's kind of interesting in that the default table space, PG default, you can relocate that anywhere you want when you're restoring from backup. You can, if you had your database in varlib Postgres, you can restore it into home Magnus. It'll work just fine. But all your secondary table spaces have their full absolute path name stored in the system tables. So those actually need to be restored into the exact same location where you started, in theory. Now, the fact is that if you look at how this is used, this field is never used. Okay, we store the absolute location in the system table, we never read it. So you can actually relocate table spaces today, it's just not supporting. But you can do that, and then you can tweak the symbolic links manually, and then you can sort of go into single user mode and update your system catalogs telling you where it is. It would be really nice to have actual support for doing this in like a way that you can trust, because it is not that uncommon that you want to restore a table space into a different location than where you had it originally. So this is definitely also something that's sitting on it. And again, this is not just for the streaming-based backups. You have the same problem when you're restoring half-a-year-old backup somewhere. Like, where in the hell did this table space go the last time? Or on a new server, because the old one is a hole in the ground somewhere. And of course, the ever-elusive incremental backups, or differential backups, or what people say. Today, we use rsync for this quite often. The protocol just streams a tar file. Could we do something a little bit more efficient than streaming your full 10 terabyte database every night in your backups? Probably. Exactly what that is not that easy. We could use something like rsync. Every time we discuss this, someone says, wasn't there supposed to be a librsync? Yeah, there was supposed to be a librsync. If any one of you guys want to finish that project, we would be happy to use it. But they never actually finished it. We also have the option taken by PGRman, which looks at page-level LSN flags to know which pages have changed. There are some issues with exactly how PGRman does this that makes it unreliable. You don't want that for your backups. But it's probably something that we can do around these lines. I don't know how we're going to do this, but we need to figure out a way to do it. The idea is obviously we can start pruning things from our log archives without having to take a complete new full backup, which is again useful if the majority of our database doesn't change. Those are the things that I have on my to-do list. I'm sure you can think of far too many other things that you would like someone to do for you. And we will be happy to review your patches once you do. So any questions on this? Yes? I would definitely recommend using PG-based backup as a generic backup tool. It's not just for provisioning replicas. It uses the replication protocol, but it's definitely a good tool for your general backups as well, as long as it only does the tar stream. It is the simple tool. If you have a huge database, you probably don't want to do it. You want to use something more intelligent, like rsync or something like that. But it is a tool to make it easy to deal with the easy situations, to get rid of the complexity. RepMGR does not use PG-based backup because RepMGR predates PG-based backup. RepMGR runs on Postgres 9.0. They may be using the tool or the protocol in a future version, but the one they use now does not use PG-based backup. Robert? It will stream it out pretty much as fast as it can get the data off disk. There's very little overhead. Once you get into the stream, it just reads a block of, I think it's 64K of data from disk and pushes it to the network and just keeps doing that. The main problem is probably that it's a little bit too performant in that it'll have a fair tendency to actually kill your I/O system on the server because you're doing too much I/O. So that is actually something that I didn't have on a slide that I've already had someone mention to me yesterday during a discussion, that we really need a way to throttle it to make it not go that fast. Yeah, it'll basically read your entire database sequentially, and that most I/O systems can do that at a very high speed. Definitely enough to fill your 2 or 4 gigabit link. That really depends on your I/O system. But yes, it can definitely interfere with your regular I/O patterns in a fairly drastic way, which is why we need a way to throttle it back somewhat. Next, Robert. It doesn't touch the buffer cache. It doesn't read them through the buffer cache. It goes directly at the operating system. Sorry, no. It doesn't use Postgres shared buffers. It reads so it will still use the operating system cache. It doesn't go through the Postgres buffer cache. It goes through the operating system file cache. Yes. Whereas obviously the operating system page cache is going to detect that we're doing a big sequential read. And usually it does something fairly smart with that. Whether it's a good idea to use ODirect or not, good question. There might be a use case for it, but we're not using ODirect for other things in Postgres in general, so it's probably kind of along that line. Yep. Well, this is sort of the plumbing made available to build such a solution. Yes, you can certainly do that. RepMGR is partially based on the same ideas. It's based on the protocol as it was in 9.0. Yeah. It's something, I mean, we're putting in parts of it all the time. We're sort of walking the balance between making just the plumbing available, because that makes the ecosystem outside of Postgres thrive and invent new things. If we put one thing in, then nobody else is going to build them. Well, that's not true. Somebody else is going to build them, but we're not going to get as many different solutions. So sort of one way is let all the guys like RepMGR or Pitter Tools or OmniPITR or whatever build their solutions now for a while, and then we see who did it the best and we copy them. That's how we do it in open source, right? Well, I think we're going to end up in, like, it's going to be completely different depending on what you're doing. It's very different dealing with this sort of small to medium-sized database than when you start getting into the, tens or hundreds of terabyte-sized databases. Then you're not going to be using the same tools. And this, I mean, in particular, the PG-based backup tool is designed for the small to medium-sized installations. It's not designed to deal with multi-terabyte installations. Oh yeah, we do that all the time. And that is one of the reasons, I mean, why we're keeping that method around. Because it still makes a lot of sense to have that method around for the more complicated scenarios. Yes. Yeah. So if it'll create one tarball per table space. Yes. So you'll get a directory with a couple of tarballs in it. They'll go in their own. Yes. Yes. All Xlogs go into one tar stream. Yeah, well, what we're doing, I mean, if you're having a lot of velocity, you're probably going to be using that one, where you're doing it in parallel, and that one doesn't write to tar files. When you're doing it in parallel, it only writes them directly to disk. It doesn't, like one file in a directory, not individual tar files. Robert? Yes. It is being worked on. Well, I mean, what's being worked on at this point is being able to run basically start and stop backup. And once you have that, then adapting PG-based backup to do that, it's going to be fairly easy. We have cascading slaves in 9.2. And it should be perfectly possible to base this off. Once we have both cascading slaves and base backup from the slave, then adapting PG-based backup to do that should be the easy part of the equation. Yes. Yep. Yep. Yeah, I mean, the streaming replication in general will it'll try to connect to the master and get it by stream. If it's not available there, it will switch to get it from the archive in the old way. It will apply the whole log until it runs out, and then it'll switch back into stream. So it'll dynamically switch between file-based and stream-based with a preference to stream-based. Okay. Well, let's go back to that one and say thank you all for listening. And I think we're going to have a break now with tea and coffee. Yes? Yeah, well, when it's not checking for interrupts, the most common case is when it's either stuck in the kernel somewhere. That can happen particularly when you're having hardware issues, or if you're calling into like a third-party library. I've seen it happen more than once in PostgIS. I've had many patches to PostgIS, just you need to check for interrupts in this loop. Yeah. I mean, if it's stuck doing I/O in sort of kernel mode, then it will not be cancelled until the kernel returns it. Yeah. Yeah, that's the first thing to look at, whether it's actually stuck in the kernel or if it's stuck in user space. If it's stuck in user space, it's almost always stuck in a third-party library. dstate is a very good way to see it. Yeah. Yeah, that's the most common way you're going to see it stuck in the kernel space. Of course, Robert will tell you to just use dstrace. Yeah. Yeah, just strace, or if you want to go hardcore, GDB. That'll tell you which third-party library it's stuck in.